Good morning. Nice. Good morning. Good morning. Alright, so we're going to get started with starting out with fleet. So we know with spring break we have a few new users. So we're just going to go through how to use the game and how to use the 3 tests that you're exploring today. If you've already been in fleet, this is probably some review, but it's never bad to look back at how far you've come, and maybe you'll see some new stuff in the dry dock that you haven't played with before. So we're going to be on for about a half hour, and then we'll sign off, and we'll come back again in 3.5 hours right after lunch, so that we can get started in really gathering data and exploring the maneuverability test. So we're going to start out with quick play so that it can load a boat for us. That way we don't have to create one from scratch, but pretty soon we're really going to start trying to figure out how to make changes to this boat. So what this text is telling us is that our boat is located off the coast of California. This is our dry dock. You can see my ship is already here because I've been playing the game. If this is your first time playing the game, you probably won't have a boat here yet. But once I hit escape, I can see my boat here. If you don't have a boat, you can just click this button and it'll load a default ship. And actually, I'll click that now so we have the exact same ship. I am right clicking and moving the video camera around so that I can look and see what's going on here. I can see the edge of my dry dock right here. This is the wall that's separating us from the sea. This is my rescue boat. This is the superstructure. This is where the captain steers the boat, where all the sailors sleep, where everyone's safe from the waves. And I have a communications tower up here too. I have hull, propellers, engine, rudder, and then the deck house. This is the superstructure. So you can see that this checklist is going to be important for us to make sure that we can use this boat. I hit play and it starts to fill my dry dock up with water. The wall comes down, and this is what's going to allow us to get out to the ocean. We don't need to steer out, so you don't need to hit any buttons now. But what we need to wait for is the ability to do a stability test that makes sure that our boat is safe to go out in the water. So what this fixed roll position is going to be is a big wave that is sent across the side of the ship to make sure that it's stable enough. And ours passed. So we're headed out on the water to test our performance. And so this morning, the goal is to try all 3 of these tests. So first we're going to try the speed test. And this just gets you used to the waves and the current and how much that pushes on this boat, and helps you think ahead to some of the design things you'll need to do. So the only thing I did is hit the up arrow, and that maxed out the throttle. If I steer left and right, that moves the steering wheel, but that snaps back. But the up and down arrow, that throttle will always stay where you leave it. So if I leave it here, it'll stay here. If I leave it here, it'll stay here. But I want to go as fast as possible. So you don't need a button mash on the throttle. You do need a button mash on the steering, but most often you start spinning in circles, so it's kind of like doing donuts in a parking lot, which isn't ideal. This time my boat the current started to push me right, and then it started pushing me back left, so actually I didn't need to do any steering. And we'll see what my time was at the end. I made time go 2 times faster. I did it in 62 seconds, and I'm going to write that down. This is information that is worth tracking over time to see how we can make this boat go faster. So, we've got 62 seconds as our base. And one thing that we all want to do is share how we're collecting this type of information, because this is a huge part of engineering. We're trying to work together to figure out how to become better engineers, and this is the kind of things that's easy to share online amongst the users. So I can go back and redesign the ship. I can go back to the logbook and see how other people are doing, or I could go back to missions and see what's next. I'm gonna actually go to missions so we can do this maneuverability test. And this is going to load the one test that we're really going to spend some time on this afternoon. And the goal here is fairly clear. There's buoys set up there, so what we're trying to do is just keep the boat between the buoys, trying to keep the red buoys on the right over here, on the right side of the starboard side, and the green buoys over here on the left, or the port side. And this is a place where you have to do some more steering, and now we're starting to think about how we can make this ship move faster and turn better. One thing that I always encourage is to try and take the same path through these buoys after you've done it a few times, so that way you can compare your data very easily across tests. I'm going to make time go 2 times faster again, just so that we can get through this. This is a more reasonable gameplay speed. Whenever I take the rescue boat out, I don't use the time 2 times, because I feel like I need every moment to control against the waves and the current when I'm using the smaller boat. But this bigger boat's much better at cutting through the waves and cutting through the currents. So we'll see what time we get on this test. So we started at 1:29, and I'm going to rate that as 89 seconds so that I can do some comparisons. Alright, so let's go back to the dry dock and see what's on this boat, make some decisions on how to make this boat go faster. So anything that I can add to the boat is under this list. So there's some cargoes and superstructures. I have no propulsion to add, but I'll show you where that is in a second. And then advanced, I can add different comms in a helo deck, so I could add a deck for a helicopter, and that will allow the helicopter to become available. And then the rescue boat. You can see when I want to check if there's more things, I click and hold. If you do have a touch screen on your laptop, you can do that also. So this has the components that are already on my ship. So I already have some communications, I already have some rescue boats, and I already have propulsion, and that's the propellers here and the engines here. Let's see what engine I have. I have the medium speed diesel. So I'm going to actually get rid of that by clicking this trash can. I can move it if I want to. I'm going to escape that. So if I hit escape, cancel editing, yes. But if I click on it again, and since the engine's inside the boat, I just can't click on it in this display. I have to go into the menu. But I just delete it. And now I can go into engines. Engines are showing up now as something that's not on my boat that I can add. So you can see here that the checklist is not complete, and my boat's isn't heavy enough. And that weight's important because it pushes the boat down in the water, so that way it's more stable for that stability test and more stable for us to make those turns better. So I'm going to add the excellent turbocharged diesel. But we can see in the medium speed diesel, the cost is $500,000. The turbocharge is $600,000. The mass is 100,000 kilograms. That drops to 30,000 kilograms for the turbocharged diesel. And this display is a little bit tricky because it's only showing the back half of my boat. So if you've done Sea Perch or Mate or any of those boat design or craft design programs, you know that you really want as much weight like on the center of the boat, and we want to put it in the bottom for this boat since it's going to have a positive buoyancy. It's going to float. We want to put the weight in the bottom so that it's more stable and it doesn't rock as much side to side. So I'm putting it right here, but now my displacement's too low because I went from 100,000 to 30,000. But this doesn't have a budget component yet, but if I was doing a mission, the missions have budgets, so that would be another thing that I want to control for. So we can add some things to the boat, and instinct is to add things that are fun, like a helideck. But when we look at the helideck, it weighs 50 kilograms. So we need to get about 100,000 kilograms back in the boat, and that helideck is not going to really help us out. We could add in, and it'd be silly to do it, but it's very possible in a video game structure, we could add in a whole nother deck house. This one weighs 85,000 kilograms, but we can see when we try to put it in here, it's too big because we have our existing deck house here. So anytime there's red, that's showing that it does not fit, so I'm going to escape out of that. But what we're going to do is add in some more water to our ballast tanks. And ballast tanks are here. If your boat doesn't already have ballast tanks, you would need to come into the plus menu to add it. What we're going to do is modify the ballast tanks that we already have. So we're going to use this water button to adjust how much is filled in each of these tanks. So I'm going to first start by filling everything up. And we'll see how that increases the weight. Oop. So 100%, so I'm up to 401,000 kilograms, but still too light. So let's fill up the side ones back here, and we will see how that adjusts. So I'm good here, but I want to balance out that weight. So I'm going to move this to 50 and move this to 50. Let's see, 69%, 60%, up that. Oop. So now we have about equal weight on either side of the boat, and we're meeting our weight distribution that we need. So we're good to go now. I'm going to click done, and now let's go test out and see how this does in the speed test and the maneuverability test. So I already know that my base number was 62 in the speed, 62 seconds, and then I had 89 seconds in the maneuverability. We're about ready to take this boat out, so I'm going to click to allow it to do the test. We passed. Now we're going to go test it on the water. So we'll go out and do the speed test, which is, again, it's just like a field goal. I max out the throttle. I might have to steer a little bit, but this is really for gathering data. This isn't as much fun as far as driving or competing in the game, but it should be done in 30 seconds or so since we made time go 2 times as quickly. Ooh, that wave almost pushed. Okay, so it was going a little bit to port. You could see I hit the right steering wheel just a touch to go straight, and this time's looking a lot better. So with one change, we went from 56 seconds to 62 seconds. There's certainly a lot of changes I could do to that ballast, and maybe I need to add more components to the ship for certain missions, and then I'll reduce that weight in that ballast. Or I guess the next test that we can do is to max out the weight, see what happens if we put as much weight as possible in that ballast tank. So I'm going back to missions, I'm clicking maneuverability, and let's see what happens when I'm maneuvering in this test. Alright, so we're going full speed ahead. I'm going to make time go 2 times as quickly right away. The current's actually pushing me. I'm not steering right now, which is interesting, but we're going to try to keep that tight line of coming as close to this buoy as possible. And then once we get past this curve, trying to go right for that next buoy on the inside of the next curve. We got 46, 47 seconds. I'm not sure if we'll get too much better than that 129, but we'll see when we get to the end. And this is again why we really want to take the same line, so this way we're getting the same data every time and we can compare it across tests. Oh, that is a lot better, right? 116, 117. So what's that? 77 seconds. I decreased the time 12 seconds. So we got 6 seconds faster on the speed and 12 seconds faster on the maneuverability. So let's go back to the dry dock. I see a good comment in here. I'm going to answer the excellent comment about where do you see ships failing the seaworthy test. When the engine is in the wrong place. And we can do that. We can actually try and make that happen right now. So let's go back into the dry dock, and I'll move where the engine is that we just put in. And this engine's really heavy too. It weighs. Oh no, this is the lighter engine. So maybe, I don't know. We'll see if it makes a difference. But we'll try and fail the test right now. So what I'm going to do is move the engine to a place that doesn't make sense, which is on the back on the side. So now we got it there, and then what I'm going to do is try to change the let's actually add in another superstructure. So we put weight on the top like this. So now the displacement's too high, but I'm going to take more weight out of the ballast and see what happens then. So ballast is under structure. We're going to change the water here. So I want all the water to be on the left side because that's where we put the engine. And then I'm going to try and take all the water I can out of the center to make it even more extreme. So take the water from back to front out. Alright, we've zeroed that out. I'm just clicking in the box and then dragging it past the bottom, and that's what brings it down to 0. I'm going to do this until the displacement gets a green check. So we want to find the maximum displacement for this boat by doing this process. Oops, let's empty these two out. Didn't see these over here. So we're at the right weight. I'm going to empty this one out just so it's even less stable. But let's go ahead and experiment and see how much. So the maximum displacement looks like it's right around 470,000 kilograms, 472-ish, somewhere in there. But let's put this to 0. We're done here. We've got a boat that looks okay, but we can even see already that there's going to be some problems. So let's see what problems looks like. So I've got 2 steering wheels, got 2 places to steer the boat. That doesn't make any sense. I put all the weight of the engine and the water on the left side of the boat, and that doesn't make any sense. So let's see how we do on this stability test. I'm going to try and move the camera as far back as possible. We'll see. The medium diesel engine might be the secret to failing though. Oh, we did fail this way though. So there's 2 issues here. We're putting too much weight on the top, and the boat's lifting too far to port or to the left side. So I'll show what that looks like. I need to move weight towards the starboard side, which includes the engine and the water and the ballast tanks. So I'm going to show what this boat looks like from the back and fill it up again so we can see what listing means, how it means that it's turning in the water. And we can look at the boat from different perspectives using this button. And we're going to look from the rear here, from the stern, and we'll fill it up again so we can just see how the water and the boat, how the boat sits in the water. And it's going to start to raise it, but already it starts to tilt. And that's because we put the engine over here. We put all the water and the ballast tanks along this side. So you wouldn't want to be on a boat where you're always leaning to the side. This is like how much it's leaning on the screen. So I'm not even going to run that again. I'm going to hit pause. Alright, we failed. And now we're back to normal. So let's let's change where the water is in our tanks. The dots do help you figure out what to adjust. I would say for beginners, the real answer is that you want to keep the dots in line, and then you really want to make sure that the ship that's being shown to you isn't tilted too much. So I'll pull up that display a little bit more. The reason I don't focus on it as much in the beginning is the hydrostatic chart is a great thing for the freshman year of college, but isn't something that really aligns with the high school and middle school education that we work with usually. So I'm still leaning, and so there's two reasons there. What I was saying with the dots lining up, we want these dots to line up. These dots should line up more. We can see that they are not aligned, so the center of mass is different. So where the water is pushing up on the boat is different where the weight of the boat is. And those kind of things make it very unstable. So now we're too light, but we still need to move that engine back to place. So under propulsion, clicking my engine again, I got that turbocharged diesel, but I'm moving it now. It was over here, now it's going to be over here. And I still got the dots out of line a bit, but at least my ship is stable from side to side. Let's add more weight to the front and see how that works out on balancing out the distribution. Oh, it's under the ones that we already have on there because we've been working with our ballast tanks. So, water in the center, just like the engine's in the center. It helps us to make sure that the boat's really heavy in the middle, but isn't too heavy on either side. And actually, so this is the exact boat we took out before. Let's max out the ballast tanks in all directions. It should evenly distribute this weight, but what we're seeing is if a heavier boat's faster than a lighter boat. And if we have any guesses, certainly list them in the chat. No worries with being wrong, just good to test out hypotheses so we can evaluate what we know. Alright, so I want to make it exactly even so we have no side to side instability, but I'm right around 470,000 kilograms, so this boat weighs 40,000 kilograms more than the 430,000 kilogram boat. Alright, so boat looks good this way. Coming over to see the dots, they're not perfectly aligned, but they're getting better. And then we can see these planes at the bottom are somewhat close, but let's fill it up with water and just see how it sits in the water. I'm a little worried that it's going to lean too far to the back, which will push the front of the boat out of the water, but I don't know. It's a little bit like that. It's not too much, I guess. Usually the back of the boat isn't that far into the water. So what I would do to fix that is probably redistribute the water even more finely in the container, in the boat. Alright, so I'm going to restart this test already. Talking too much and not steering enough. So I want to do an exact test like I did last time. So I max out the throttle right away, and then I can click this. The waves and the current makes each one of these tests a little bit different, unfortunately, but it's our best way to test. And if you feel like the waves and current were just too strong in one of your tests, run it again and just average out the times, and that way you can kind of get a better read for the data for the new boat that you're testing out. But we are at 48, 49, 50. We'll see if we get there. So 57, it added 1 second. 1 second's pretty close. But let's go and check out the maneuverability test, and if that time is also a little bit longer, then we made a mistake. And this would be something that we'd want to go back and adjust, that the heavier boat isn't the right solution. Trying to stay to the minimum is better for speed, for tests where we want speed. So again, I'm maxed out the throttle right away, trying to steer towards this first buoy on the inside of the turn, And now I'm steering for the second buoy on the inside of the next turn. Time seems pretty good. I'm not sure it's better. This line isn't either the best. Steering could have been a little bit better, I think. Definitely is not exactly like the last time we did this test. The last time we had 77 seconds. We're already well above that. 127. This is almost back to the 89 seconds that we started out with. This is 87 seconds. I want to run this again just to see why that was so off. And this is just the kinds of testing that engineers do all the time. You want to see what works and what doesn't work, and if something seems a little bit off, go back and redo it just to see why it was off. So this boat, I thought it would get through the waves a little bit better because my center of gravity is lower, but it's not really feeling that way. And so I'm going to try and hit this line. I'm doing a little bit better job steering, honestly, than the last time. So now it's able to go straight through here a little bit better than we were before. And I'm not thinking this time looks any better than the last time. So maybe this design is worse for maneuverability and it was slightly worse for speed. Well, it's a little better. 1 second better. So this is just the time. This 86 seconds, 87 seconds. We've added 10 seconds of time by adding weight to the boat. So we know that we need to go back and take out that weight and then think about where we want the minimal weight that we put in the ballast tanks. I'm going to go back out I'm going to go through the logbook just so we can see that before we get out of here. These are all the missions that we can do. And there's different leaderboards, and this explains what you're supposed to do in each of these missions. You can see some of the missions have different weather too. This one is foggy, and that changes some of the comms that you need to put on your ship. But what I'm going to do is go out so we can do one last test. And I'll show you the search and rescue test, and then I'll let you get after it. Alright, so we're back in the dry dock. I need to add rescue equipment, and my boat's over budget. So I'm going to take this off for now. See if that makes it. So now I'm 39,000 under budget. I need to add cargo for the rescue equipment, which is this green box. I want to put it again just on the center. So now I meet the criteria, but I want to have something on this boat that'll help me rescue people. So let's add on the helo deck and then compare the costs of my rescue options. So I can either add in helicopters, which cost $350,000 or $300,000, which do not seem good. Or I could add rescue boats, which cost $120,000 or $160,000. So my previous solution was the cheapest solution for this, but I can't afford all that's on here already. So I'm going to take off this communication tower, this radar tower. So my displacement's too high, which reminds us that I want to go in and change all that ballast tank stuff so that it's as light as possible. So I'm going to first take all the weight out of the sides. And this just takes a little bit of time. I apologize, it's not the quickest interface, but it's the place where you can really make some fine-tuned adjustments that may not show up honestly in the speed test, but if you start having to go 1.5 miles offshore for the search and rescue test, then this is where you can reduce that time in the 4 minutes-ish it takes to get out to that sinking ship. And that's probably data that you want to record for yourselves. So we are too low now. Let's put a little bit weight back in here. Should have paid more attention than talking. Alright, so we almost are at the right. Trying to go to, there we go, 428,000 kilograms. So we're done here. We have all green checks. So we're going to do the last test. Alright. probably should have brought the helicopter out, but you can play around with that if you want. More tomorrow. Tomorrow is going to be a big test of all these equipment. Today is much more about getting the main ship to pass these tests and to actually really max out your time in the maneuverability test this afternoon. Alright, so now I can go and do the rescue practice. Don't have the required components. So, I'm a minute over anyways. I'm gonna... Let's see why that's not happening. Alright, well, let's call it there. I'm gonna have to investigate a little bit more, and that's going to be a waste of time while I think through what we're missing on here, and I'll fill you in on the answer when we meet back at 1. But go ahead and give this a shot for the maneuverability test and the speed test. Good luck.